Assalamualaikum and salam sejahtera to all the panels and also my final year project supervisor and Sheikh Muhammad Fadli bin Abdul Zaid. My name is Noor Syakila Binti Mazmin. My metric number is CE180047. So today I will present my final year project 1, which is the title is Solar Panel Monitoring System based on IoT. So, introduction of this project. Renewable energy sources are proven to be reliable and accepted as the best alternative to meet our growing energy needs. So, solar panel energy is one of the most promising and reliable energy source. So, as we can see, it is because solar panels are used to convert solar energy into electrical energy. So, in 2020, a total of 138.2 gigawatt of solar panel was installed worldwide, representing 18% growth compared to 117.6 gigawatt added the previous year. So as we can see, since in 2020 we have global pandemic, so the solar panel has been highly demanded than expected in GMO. So third, solar panel system monitoring to monitor the accuracy and performance of solar panel system. And then this technology can help user to monitor performance solar panel system faster and also wherever they are using the Internet of Things. The feature of this technology can contribute to its popularity among developer and user because a solar panel have a good potential and widespread. So the problem statement. The operation and function of solar panel system can be affected as a result of various environmental factors such as impurities, radiation, temperature, and others. So, therefore, monitoring on solar panel system is very important to detect a disturbance that occur in the operation and function of the solar panel. So, the second point is power companies or communities that place solar panel network to household need to monitor the solar panel network where the solar panel are located. So this method is very inconvenient and takes a long time for a user to monitor their solar panel system. Then, the solar panel monitor system is built to make easier for user to view a voltage, current, and power reading through LCD or via smartphone using Internet of Things. And then it is an efficient solar panel monitoring method which can improve the performance and accuracy of solar panel PV system. So the objective of this project is there are two objectives. One, to monitor the voltage, current, power, and temperature for solar panel using Internet of Things. Second objective, to investigate the system performance from two different solar panels position. Scope of work. First, display the solar panel parameter on LCD and smartphone. Second, monitor a system of solar panel quickly and anywhere using Internet of Things using Wi-Fi module ESP8268. And then this project is using Blink application to create the smartphone application. So for the literature review, we have three parts project, which is real-time data acquisition of solar panel using Excel. Second, solar panel data monitoring using LabVIEW. Third, solar energy measurement using LCD. So the first literature review has been written by A.L. Hamomi S. Motahe, Charles A. L. Ghazal, A. Dorish in 218. And then the writer for the second literature review are same with the writer for first literature review. And the third literature review has been written by Siti Emily Muhammad Hilmi in 228. 218. So the function of the first literature review is to measure the current, voltage, and power, same as for the second literature review. And then at the third literature review is to measure temperature, light intensity, voltage, and power of solar panel. So next, in the first literature review, they are using a component which is a current sensor INA 169 and voltage sensor F03106. Same as for the second literature review, they are using current sensor INA 169 and voltage sensor F03106. And then for the third literature review, they use a current sensor module, voltage divider, LDR sensor, and temperature sensor. So the output for the solar panel using Excel will display the output in the Excel. And then for the second literature review, it will display the output in a lab view. And the third literature review will display the result, the output at the LCD. So in my project, which is the title is Solar Panel Monitoring System based on IoT, I will use the project is to measure the voltage, current, power, and temperature. So in this project, I'm using the component for the current sensor ACS712, voltage sensor F03106, temperature sensor LM35. Why I'm using ACS712? Because the price for ACS712 is more cheaper than current sensor INA 169. And then I will display the output at the LCD and smartphone using Internet of Things. So in my project, I'm also use solar panel polycrystalline solar panel because it have a different efficiency rate, not much different than monocrystalline. And then also because the price for polycrystalline is more cheaper than monocrystalline solar panel. So this is methodology of my project. So in this project, I will use two solar panel as an input, and then I will use two voltage sensor, current sensor, and temperature sensor. And then for the data processing, I use Arduino Uno R3 with at Mega 328P. And for the output, I will display the result at the LCD 16 time 2 and ESP and using ESP8266 for IoT. And then the data that have been received from the ESP will transfer to the Blink cloud, and then the Blink application will be created in the smartphone to create a smartphone application. So next, this is my project flow, which is I will start the project, and then and then the data will collect from the solar panel 1, solar panel 2, and it will detect the voltage sensor, and then detect the current sensor, and it will calculate the power and detect the temperature sensor, and the result will display in two ways, which is first the result for the solar panel 1 and solar panel 2 we display at the LCD, and then it will stop the program, and then the data from solar panel 1 and 2, the result from the solar panel 1 and 2 we transfer to the ESP8266 Wi-Fi module, and then a Blink IoT application will define the Wi-Fi name and password. And then it will display the voltage, current, power, and temperature of solar panel 1 and 2 on a smartphone, and the program will looping to the starting. So here is the result for my project, first I do a simulation for F03106 voltage sensor and current sensor ACS712 with LCD. So I will play the video. So in this video, I run the simulation and the LCD will display the solar panel one first, which is the voltage, current and power. And then it will display the result for solar panel 2, voltage, current and power. And then it will start back display the solar panel 1. So for the second result is solar panel using sensor, voltage sensor and with LCD. Is the hardware for solar panel use a voltage sensor with LCD. So as we can see here, the result at the multimeter is to prove that the voltage from the solar panel that have been detected from the solar panel that has been displayed on the LCD is correct. So as you can see here is 7 volt. So it will display 6.5 volt. It is because this we are use clan meter, so it can show float number. So I will proceed to the third result, which is testing a data to Blink application. So as we can see here, we use a serial monitor Arduino here, and this is a Blink cloud. So as we can see, the result from the serial monitor Arduino is same as a voltage display at Blink application, and same as the result at the ammeter. So as you can see here, show 4 volt, and then the Blink will show here show 3 volt, and the Blink will show 3 volt also. So we play back. So as we can see here, show 5 volt, and then the result here show 4.5 volt also. So the conclusion of this project has a useful design and work system for them, especially solar panels installation or production companies, to produce and ensure the performance of the solar panel work well. This is because a current, voltage, irradiation and temperature can affect a solar panel efficiency. So solar panel monitoring system in real time is to monitor system in PV power plant in any time and anywhere. It is very important and urgent in some case for analysis, problem solving and in issue decision making. So that's all from me. Thank you.